Okay, so the first section of the review is about changing forms. So you have to know how to convert from a log to an exponential and then an exponential to a log. So this one has a log written. So what I'm going to do is I'm going to go ahead and bring down the equal sign. The base of this log is 4. So we're going to bring that down and make it a big 4. And then we're just going to flip-flop the rest of the stuff. So that 6 comes up and becomes the exponent. And then 4096 goes over here. Same pattern happens over here. You take this 8, you make it big, and then you just flip-flop these guys. So 8 to the 0 is equal to 1. Then vice versa. It doesn't say log anymore. It says it's got an exponential, so we have to turn it into a log. So this stuff works kind of the same way. You'll notice that the base is 12, and the base is the one that has the exponent on it, so that's where the log's got to go. And because the base is 12, that's the base of your log. Then these two just flip-flop. So we have 17.8 and then 3. Next one, base is 9, so that makes this a log of base 9, and then these two flip-flop. So 3 goes here, and then 1/2 goes over here. Now the next one says evaluate the following expressions with and without a calculator. We're just going to go ahead and go like this. Probably red, so it looks better. And then, we should use the calculator. So I'm going to review how to find all the buttons and stuff. So when we want to find a log base 2, we cannot use this button here. That's the button that's right next to the x. And that button doesn't work for this problem because it's not a base 10. That button is only for base 10, so I can't use that one. So to access a log base 2, I have to hit F4 and then F2. Then I can type in whatever I want. So then I have log base 2 of 1/8. And that right there is going to give me -3. Next problem, I've already got it up in the calculator, so log base 16 of 4. Now we don't write decimals on this one, so I'm going to just go ahead and convert that if it'll let me. There we go, so that answer is 1/2. So basically that means 16 to the 1/2 gives us an answer of 4. This one right here means 2 to the -3rd gives us an answer of 1/8. Okay, now actually solving. So when we solve and there's no logs in the problem, our goal is to ultimately make the bases the same. If we can make a match, the problem's super, super simple. So we look at the bigger number, 49. Can 49 be written as a 7? Absolutely, it's 7 squared. So you have 7 squared equals 7 to the 2x minus 3. Once you can get those bases to match, we don't really need them anymore, so we can just cross them out. So now we're left with 2x minus 3 equals 2. Then we add 3 to both sides. That's 5. That's 2x. And then we just divide by 2. So x equals 5 over 2. Next problem is similar, but you're going to notice that you can't change 125 into a 25. And I know that because 25 squared is already bigger than 125. So if you can't change the big one into the small one, you have to see if you can change the small one into something else. So the small one in here is 25. And I know for a fact that 25 can be written as 5 squared. Now, because that 25 already had some stuff up there, we have to put it back, but we have to put it in parentheses. Then we do the same thing to the other side. So when we move that 125, that's going to turn into 5 to the 3rd power. And because it already had some stuff up there, we're going to put it back in parentheses. So the goal was to make them match. Now they match, so we can cross them out, and then we can just solve what's left. I'm going to save some time here, and I'm just going to distribute now. So this is 4x plus 2, and this right here, when you times that, it's just 3x. And our goal is to try to get x all to one side. So I'm going to go ahead and, I don't know, how about we subtract 4x? Subtract 4x, and so that x was already kind of by itself over there. So I have negative x equals 2, so I divide by -1 to get x completely alone. So that gives me -2 for my final answer. Okay, now, this problem, it only has one exponent in it. So the first thing we want to do is we want to isolate the exponent, or the base, I should say. So I need to get this -1 out of here first. So that's 10. Then we have 2e to the x. Now we want, let me make this red. We want this e all by itself. So I have to get rid of the 2 next. So I have to divide that by 2. So I have e to the x equals 5. Now clearly we can't turn 5 into an e. So what we have to do here is we have to use logs to solve this. So what I'm going to do is I'm going to take the ln of e and the ln of 5. And what that allows us to do is that allows us to bring this guy over here. So it drops it down. That's one of the log properties, one of the 3 basic rules of logs that you're supposed to know. Now the nice thing about having e in your problem is ln of e is 1. So if you have x times 1, that just gives you x. So x equals the ln of 5. And then I guess I'll go ahead and type this in the calculator. So ln of 5 is a long decimal. So you could either leave it as the ln of 5, but I'm going to write it as 1.609. And I don't remember seeing anything in the instructions about how to round it, so I'm just going to keep rounding it to 3 decimal places. Okay, number 10. I can't change a 40 into a 7, so I'm basically ready to do that ln stuff. So I'm going to ln here, I'm going to ln there. So that means this entire exponent can come out to the front. So this is going to say x minus 2 multiplied by the ln of 7 equals the ln of 40. We need to isolate those parentheses, so I have to get rid of the ln of 7 first. And then I'm left with x minus 2 equals, I'm going to leave that for now. It's a decimal, but I'll figure that out at the very, very end. And then over here, I don't really need those parentheses anymore, because it's like having a 1 in the front, and 1 times anything is not going to do anything. So now I can actually solve this for x. So I'm going to add 2, and then I'm going to add 2 to this side. So that crosses out. So x equals, and let me type that in the calculator. So ln of 40 on top of the ln of 7. Then we go to the right and plus 2. So this one says 3.8957. I always round to the 3rd number just because that's how we do it in college algebra. But again, you're going to have to read your directions on the test to see how far it wants you to round. So I'm going to round to the 3rd number. So that's a 5. The number next to it is a 7. So this is going to go to 3.896. Okay, now we get into logs. Now when we do logs, we don't want to have more than 2 logs on one side, or more than 1 log on one side for that matter. So over here on this left side, we have to combine these into 1. So I'm going to write log base 3. And because this is a plus sign, that tells me that I have to actually take this and multiply it to that. So I'm going to go 4 times y plus 8. That's all inside of my log. And then I also don't like having numbers out in front of the log, so I'm going to bring that up here. So I'm going to go log base 3 of y squared. Now, this one is sweet because once you can get those logs, 1 log on the left and 1 log on the right, those logs just cross out. So we can now solve what's left. So let me go ahead and rewrite this as y squared equals, let me also distribute this, 4y plus 32. So then what we're going to do, anytime there's a y squared, we can use the solver. So I'm going to move this stuff over to the y squared. I'll bring this over here, but I'll also bring this over as well. So this is going to say y squared minus 4y minus 32 equals 0. And we all know what the big fat red 0 means. Anytime we have a problem equal to 0 like that, we can go into our solver to find 2 answers. Polynomial solver, degree 2, 1 is in front, negative 4 is in the middle, and then negative 32 is the 3rd term. 32. So this problem is asking us to actually solve it. So when we solve this, we have to make sure that we know what we're doing. Factoring is when you flip the sign, and solving is getting the answers from the calculator. So we're solving. So the answers are x equals 8 and x equals negative 4. Now when we're doing logs, you have to check if you end up with any negatives inside of your logs. So if I put an 8 right here, that's positive. If I put an 8 right here, that's also going to be positive. So that's not an issue. If I go back and try that with the -4, let me put this in red again. So if I put a -4 here, there's our problem. That doesn't happen. That's not allowed to happen. So that means this answer right here is extraneous. So I'm going to put this up. Anytime you have a log or an ln, the stuff in here can be negative. Negative, I'll write the whole word out. Can't be 0. So if you see any of that stuff, that right there is not allowed inside of those logs because it gives you an error in the calculator. Okay, number 12. All right, it's already got an ln on the left and an ln on the right, so we can just cross those out right away. And we can get to solving. So 3x plus 1 equals x plus 5. I need x all to one side. So this is 2x plus 1 equals 5. And then subtract 1 from both sides. So 2x equals 4. Then we can divide by 2. So x equals 2. Now the thing about logs, you guys, is you got to check and verify to make sure that it doesn't give you negatives or zeros inside the parentheses. So if I do 3 times 2 plus 1, that is not 0 and that's not negative. And then if I put a 2 right there, 2 plus 5, it's not 0 and it's not negative. I don't care what it is, I just want to make sure it's not 0 and it's not negative. So this one is not extraneous. Okay, now there's only one log. Anytime there's only one log, we have to try to get the log all by itself. So the log part is just this stuff right here. So that's my log. So the first thing I need to do is get rid of the 3. Get rid of that 3 by subtracting it. So I have negative log base 8 of 3x equals -2. Now that log is still not by itself because it's got the negative out in front. So what we have to do is we have to treat that negative like a -1. So I have to divide the whole problem by -1, which flips all the signs. So that's log base 8 of 3x is equal to 2. And once we get that log isolated, now we can convert into exponential form. So I'm going to take this base 8 and I'm going to drop it down. And now I'm just going to switch this stuff. So that 2 comes over to this side, and then 3x comes over to this side. 8 squared is 64. If I want x by itself, I just have to divide by 3. So x equals 64 over 3. Now that 64 over 3 is positive. So when I stick 64 over 3 here and times that, that's positive and it's not 0. So we're good there. That checks out. Okay, 14. 14, it looks like there's 2 logs again. So we always have to make sure that we combine our logs. So these 2 logs have to go together. So it's going to be a log base 7. You notice what's in between? You've got a plus sign, so that indicates that we have to times our 2 logs. The stuff inside of our 2 logs, those are called arguments. We've got to times them together. So this is 8 times, not 8. 8 times x plus 1 equals 2. And we can go ahead and convert. There's only one log, so anytime there's only one log, we convert. So this right here comes down. That's a 7. Then these 2 things trade spots. So 7 squared goes here, and then 8 and x plus 1 goes there. So this is 49. This is going to be 8x plus 8. And then I just have to subtract 8. That's 41. And then divide by 8. So x equals 41 over 8. If you go and put 41 over 8 here, it's positive. So when you add more to it, it's still positive. So we're good. That's my answer. Okay, so now it says to describe the process to solve an exponential equation when the bases can be made the same. So that's kind of like one of the problems that we did. That's kind of like, where is it? It's kind of like this question here. So if you can rewrite the base, you rewrite them so that they have the matching base. It doesn't matter if it's that one or this one. These both can be rewritten so that they have the same base. So that's basically step 1. So let me grab my skiing pen. Step 1, rewrite with same base. Step 2, cancel bases. So when you cancel the bases, you can set your exponents equal. then you solve. And that's pretty much it. I mean, you can check when you solve, but exponentials, they don't cause any issues when you have positive or negatives and zeros, so I wouldn't even bother checking. If we're solving a log that has logs on both sides, it's very similar. If they have logs on both sides, you're going to basically cancel the logs. And then you're going to set the insides of those logs equal. Solve. And once you solve, you're going to check for extraneous. You check for extraneous again by plugging your answer in for the x inside the parentheses to make sure that it doesn't give you a 0 or a negative. Okay, so this one says list the steps. I'm going to list the steps, but I'm also going to solve it as I do it. So we can't change 17.8 into a 10. We can't change a 10 into anything. So the first step is going to be to convert. So the base has already been isolated. If there was any other numbers besides that 10 right there, I would get rid of those first, but there isn't, so the first step is going to be to convert. So we're going to change this into a log. So this is log base 10. These are going to flip-flop. So 17.8 equals x minus 5. After we convert, we're going to add 5. So I'm going to add 5 to get this x by itself. And remember, this 17.8 is inside the log. So when we add the 5, those cannot add because that's not really a 17.8. It's a 17.8 inside of the log. So this is log base 10, 17.8 plus 5 equals x. And then that's just a decimal. You can go ahead and check that out real quick. So that decimal is, this is log base 10, so I can just use that button. And that's 17.8, and then plus 5. And because the problem was an exponential, we don't really have to check it. I mean, you could if you wanted to. So if I did 10 to the, I want that whole answer in there. So shift answer minus 5. That should give us 17.8. So that works out perfect. Okay, number 18, they want us to do the same thing. So if you notice right here, there's 2 logs. So when we put 2 logs together, that's called condense. So we're going to condense the logs. So this is going to be log base 4 of 3 times negative 4x equals 2. Next, I guess we're going to convert. When we convert, this is going from a log to an exponential, so this 4 turns into a big 4, and then everything just flip-flops. And then we're going to multiply. So this is negative 12x, and it's 16, and then we're just going to divide next. Divide. So divide by negative 12, divide by negative 12. So x equals 16 over 12. We can divide both of those by 4, so this is negative 4/3. Last thing we have to do is we have to check. If I put in a negative 4/3 here, notice how this one is already negative. A negative and a negative make a positive, so we're good. So that is not extraneous. Okay, number 19, we got to find all of our information from the graph. So our intercept in this one, because of our asymptote, you'll notice that the asymptote is a horizontal. That means this problem cannot be a log function. Let's see, what else can we say about this? We can say that the intercept is right here. So that intercept is at 0, 1. Our asymptote, you saw that it was on the x-axis, so that's going to be a y equals 0. Now that asymptote is connected to your range. Because it's treated like a border, it can't cross below that dotted line. So that means that our range has to start from 0 and go to infinity. Also, because of the type of function this is, this graph always goes left and it always goes right. So the domain is going to be negative infinity to infinity. Then our end behavior, as you go to the left, that left side approaches the asymptote. So the asymptote was at 0, and then as you go to the right side approaches infinity. And you can see there's some connections here. The asymptote helps us figure out the range, and then the range helps us figure out the end behavior. And then when they ask us what type of function this is, they want to know, is it an exponential growth, is it an exponential decay, or is it a log? We already know just based on the asymptote that it's not a log, so it's between growth and decay. This one is going to be exponential growth. Just based on the shape, growth functions always start off kind of flat and then shoot up after a certain point. Okay, number 20. Number 20, you can see now the asymptote is flipped. You can tell that the asymptote goes this way now. So that right there means it's going to be a log function, first of all. And the way I taught it in my class is this is log. So the L kind of looks like the dotted lines for the asymptote. So that's how I know it's a log function. Other things about this graph, the intercept. You know the intercept is right here at 1, 0. Your asymptote is at x equals 0. And remember, the asymptote in this one is going to connect to the domain. Because of the way the border is written, that border doesn't let the graph head over into the negatives on the left. So that means the graph goes from 0 to infinity. These graphs, they do, even though the graph looks like it stops, they do go forever. So that goes down forever and then right forever. The range is connected to your end behavior. So the left side goes down, so that's negative infinity. And then the right side goes up, so that's positive infinity. Let me tell you guys a life hack also. When you guys do these end behaviors, you're going to notice this guy right here. That is the asymptote. Okay, so there's that question. Then it says describe the inverse, or describe the relationship between ln of x and e to the x. Now guys, you got to remember, ln is really just log base e, and this is base e. So what you guys need to understand is anytime you see a log and an exponential that have the same base, they're basically going to be, what do you call it? Inverses of each other. So that's what I'm going to write here. I don't know why I put an asymptote. They are inverses. There's going to be one just like that on the test. Now we want you to actually find the inverse. So if I find the inverse, remember how you do an inverse. You switch your x and your y. So this x goes here and y goes here. Everything else stays exactly where it's at. So it's going to be log base 2. And then in parentheses, this is y plus 1. So if I want to find the inverse, I've already switched the x and the y, and now I have to get y all by itself. Well, I can't do anything, so I kind of have to switch forms. So I got to take this 2 and make it big, and then I've got to flip-flop the two things. So this x comes over here, and then this y plus 1 comes over here. So then we subtract 1, so we get y equals 2 to the x minus 1. And that's our inverse. Now they want us to use that on the next question. So 2 to the x minus 1 for our inverse. We'll call that f inverse of x. They want us to graph both of them and make a table. So I'll go ahead and do that in the calculator. So I'm going to go over to the table. And I'm going to put in log base 2. So to get to the log, you're going to have to hit option, F2 for calc, and then F4 for the log. So this is log base 2. And remember, guys, when you type in the x, it has to be the x under the red alpha button. If you hit any other x's, it's going to say some weird error stuff. Okay, so the numbers they want are 0, 0, 1, and 3. So 0 is 0. So that's here. And then they want 1. So there's 1, 1. So that's here. And then 3. 3 is at 2. So 1, 2, 3, 1, 2. And then they want 7. 7 is at 3. 7, 3. So you can kind of tell based on this guy right here, and also when we set this equal to 0, that's where you get your asymptote. So you're going to have an asymptote at -1. So let me add that into my picture. So I have an asymptote here. So for this picture, the graph is going to go like this. And we know it does that because that's the shape of a log. Now the next one is an exponential. So let me get out of this and go and type the exponential in. So 2 to the x. Oops, I forgot to put the exponent. 2 to the x. And then -1. Make sure you put subtract 1 and not -1 because that'll also give you an error. So they want the number at -1. So -1 is at -1/2. Let me put all the numbers first and then I'll go graph them in a different color. They want 0, so that's at 0. And then 1 was at 1. And then 2 was at 3. There we go. So I'll do this one in blue. So -1 and then 1/2 negative is right here. Then 0, 0. Then 1, 1. And 2, 3. Now, according to how this guy is set up, asymptotes for this, that's the asymptote. So my asymptote for this graph would be at -1 like this. And then my graph itself would come flat, 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 hit those dots, and then start to curve away. So you can see that they are inverses of each other. And you can tell they're inverses of each other because it's a reflection across this perfect diagonal right here. A reflection is when you pretend one of them is wet paint and you fold the page along the dotted line. And now they want us to graph. So graphing is all done in the calculator. I'm just going to find the asymptote. In a log, asymptotes come from here. So I have to set that equal to 0 and solve it. So I'm going to go ahead and take, let me go on, x minus 2 equals 0, add 2, so x equals 2. So if you're confused on how to draw your asymptote, just remember, these asymptotes are drawn based on the L. That L is like the first line of that dotted line. So that means at 2, the dotted line has to be vertical like this. Try to make it as straight as you can. And we go into the calculator. The rest is calculator work. So let me get out of this. Let's delete that. Yes, I want to. So we're going to go option, calc, F4. So this is log base 4 of x minus 2. And then plus 1. Plus 4. So remember, you're going to see errors in this because you can't have a negative inside that log. So we're going to have to go up to the asymptote. The asymptote was at 2, so it should start up right after 2. So we're going to have a point at 3 and 6. So 3, 1, and 6, 2. So 3, 1, and then 6, 2. Let's get out of the dotted line. 6, 2. I'm pretty sure that's all we're going to be able to fit on here. Yeah, I think that's as far as we can go. But we know the shape of a log. Log shapes go like this towards the border and then drop down and then go slowly up. Okay, next one. 4 to the x plus 1 minus 2. So let's go back to here. We're going to go up. 4 to the x plus 1 and then minus 2. So you'll see that this table right here, it's real close to -2, and the reason why is because -2 is the asymptote. So that -2, this one is going to be at y. And that has to be a horizontal because it doesn't have the L to draw that dotted line. So at -2, yeah, that's what I want. At -2, we're going to have a horizontal asymptote like this. And that explains why we see so many numbers really, really close to -2. So we're moving away. So our first point is at -1, 1. First point that we can actually graph. Why is it giving me a dotted line? Scroll some more, 0, 2. 114. So that shoots off the graph paper. So that means that we have exponential growth like this, and then it shoots kind of up like that. So there's our answers. Let's see what else we have here. I did 24, I did 25. Number 26, it says, suppose the population of rabbits introduced to a small island. As the time goes by, the rabbit population increased by 14.5%. The table below gives the population data. So it looks like it's over 9 years, 10 years, 0 to 10, 0 to 9, and then goes all the way to 85. We just got to break this graph up to try to spread it out as much as possible. Let's try counting by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. Oops, I don't want 70, I want 75. Just kidding. 75, 80, 85, 90, and then 95. So I'm just trying to stretch out the graph as much as possible. Let's see what else we have here. We've got to go from 0 to 9, so I'll just skip a line to stretch this out too. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You notice how I did it, like, I don't want the graph to be a tiny little thing in here. I want to spread it out as much as possible, so that's why I'm skipping a line when I do this stuff. Then I just plot my points. So at 0, there's a point at 25. We're going to have to estimate, obviously. At 1, we're at 29, which is just under there, because that's 30 at that line. Then at 2, we're at 33, right here. At 3, we're at 38. So 35, 38-ish is about right here. 4, we're at 43, so that's just under 45. 5 is at 49. So this line right here is 50, so it should, oops, did I skip a line? Yeah, I messed up. Let me move this dot over. So about right there. There, that looks better. Didn't look like it was curving right, so that's how I knew I was off one line. So at 6, we're at 56. So 55 is there, so 56 should be right above it. 7 is at 65 exactly. And then 8 is at 74, which is just under this one. And then 9 is at 85 exactly. So 85 would be this one right here. So this is exponential growth for sure. Curving up. Part B says, create an exponential model. So in a model, we have to plug in this amount and this number here. Remember, this is the initial, which is basically the starting amount. Start. A weird way of writing start. The starting amount, it's in the story. It says, suppose population of 25 rabbits. That's the starting amount. Starting amount is also right here at year 0. So we're going to plug in a 25 here. Now R is in the story. R is at 14.5%, but we have to convert that. 14.5 moves left 2 goes here, so that's going to be 0.145. So we got to stick that in 0.14, okay, 0.145. And then we can close this up and then put the exponent of x and y. And then we can simplify this. So this is going to be 25, 1.145 to the x. That's the answer for the formula. We put y equals here, squeeze that in. Now it says use the model to find the population for 20, 30, and 50. Oh, they did a bad job here. This should have been a T because that's how they're naming this right here. So this should be a T and this should be a T. Okay, so this is all calculator work. So they want us to plug in 20 to our model. And this is rabbit populations. So I guess I'll write this down. Y equals 25, 1.145 to the 20th power. 25. And then parentheses 1.145 to the 20th power. 375 rabbits. And I'm not using decimals because you can't have half a rabbit from rounding to the nearest whole number. The next one we're going to do is 30 years, so it's 25, 1.145 to the 30th power. I'm too lazy to type it all in again, so I'm going to go up here and just change that 20 into a 30. So that's 1,452 rabbits. And then the last one, let's see, this is going to be 25, 1.145 to the 50th power. We'll go back up and change that 30 into a 50. 21,787. I'm going to round that to 21,788. 21,788. And that's what exponential growth means. Exponential growth means it kind of starts off slow, but at some point, that thing just kind of starts shooting almost straight up. And that's how retirement accounts work. You want to retire rich, you start as early as possible because you don't see this thing start to shoot up right here until about 30 to 40 years. Okay, next one. It says the table below represents the number of participants at a tennis tournament. The tournament starts with 256 players. During each round, half the participants are eliminated. Okay, so in round one, there are 256 people. Then half the people get cut out, so that leaves us with 128 people. And for the next round, half the people are out, so that's 64. Then the next round, half people are gone, and then one more time, half the people are gone. So again, we're going to try to, this thing goes all the way to 256, so we should try to stretch this out a little bit. So I don't know, let's try like 30s. How about 30s? 30, 60, 90, 120, 150, 180, 10, yeah, 10, and we got 240, 270, 300. Oh, that's perfect. Okay, and then this only goes to 6. See how many lines we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got plenty, so I'm going to go 1. Every third line, I'm going to make it 1. 1, 2, 2, 3, 4, 5, 1, 2, 6. Okay, so now we plot the points. 256. I don't know, 240, 250, 60. We'll go probably around right here somewhere. Oh, I should probably put that at 1 though. Put that over here. And then 2 is at 128. Significant drop off. It goes, I don't know, around here somewhere. And then 64 for 3. 64 is just above here. And then 4 is 32. 2 just above here. And then 5 is 16. 5 is 16, half of that right there. So you can clearly see this is exponential decay. Oh, I guess I won't put that part right there, because that's where the story actually starts. Then it says write an exponential decay model for this. Okay, well, let's see what we got here. To write a model, so I don't like that they keep putting X up there, but whatever. This is the starting amount. The starting number of players in this tournament was 265. Is that what it was? 256. Sorry, I'm dyslexic. So 256 goes here, and then 1 minus. Now, I don't think they explicitly say the rate, but they kind of do, because they say 1/2. 1/2 is 50%. So if we convert 50% to a decimal, the decimal is right here, 1, 2. That becomes 0.50, which when you have decimals, you don't need the 0 on the far right. So we're going to put that 0.5 right here, and then we've got T. or x, or whatever they're using there. So there's the formula. I think that's all they want us to do. They only want, oh, I guess I can simplify that. 256.5 to the x equals 1. That's the answer for part C. Okay, next is all review. So we've got to simplify. Simplify means factor and cancel. So let's see, I need a calculator for that top one because that's an ABC question. This one doesn't have a GCF. What am I doing? I need the solver. This one does not have a GCF, so I can go ahead and just stick it into the solver. So it's 1 for the front number, -3 for the middle number, and then -10 for the third number. 1, screw up. And then I want the factors though, so I have to flip these. If my answers to this are x equals 5 and x equals -2, that means that my parentheses are actually x minus 5 and x plus 2. So don't get that twisted. We are factoring. Factoring has an opposite sign of its solution. Then x squared minus 4, that's a difference of squares, so I can just square root this and square root that. Oh, my pen is not working right, so that's going to give us x plus 2 and x minus 2, which, by the way, we get restrictions. X is not allowed to be plus or minus 2. That comes from the bottom by setting them equal to 0. And then we cancel. So this plus 2 and this plus 2 cancels, and our final answer is x minus 5 over x minus 2. And you cannot cancel those x's because technically these are still in parentheses, and with parentheses, it's all or nothing. Let's see, 29. 29 is solved. Now this guy's got a square root, so we have to get rid of everything that's not inside the square root first. So I need to subtract 7 from both sides. So that's 8, and then the square root of x plus 2. Now I need to get the stuff out of the square root, so I need to use exponent. So this is going to be x plus 2 equals 64, and then I subtract 2. So x is 62. And a quick check. 62 plus 2 is 64. Square root of 64 is 8. 8 plus 7 is 15. So that checks out. Okay, simplify. Simplify is times this. So 24 minus 56i minus 9i, and then plus 21i squared. Now, one thing about the I squared is equal to -1. So 21 times -1 would be -21. So if you have an I squared, you can get rid of it and flip the sign. So that means these two are now like terms. So 24 take away 21 is 3. And then -56 minus 9 is going to be -65 i's. And if you guys forgot, you can actually do this one in the calculator without having to show any work whatsoever. Just have to make sure that your calculator is set up correctly. So let me type it in first and see if it's actually set up. And if not, we can fix it so we can go through that. I wish my calculator would stop doing that. That makes me real mad. Oh my God. Okay, here we go. Let's see. Parentheses, 8 minus 3. I is shift 0. Close the parentheses, and then we have 3 minus 7 shift 0. Oh, I forgot the 3. Sorry. There should be a 3 in front of that I right there. Okay. Now, if it would have said like non-real error and all that stuff, you have to go into your settings. So you go Shift, Setup, or Shift Menu. Go right below where it says Angle, and it needs to be in complex mode, which is the A plus BI stuff. Actually, it looks like it didn't even have to be. It still worked. So that's awesome. Okay, last one. Factor. Factoring is the solver. This is an ABC problem. So let me go into the solver again. This is a polynomial solver, degree 2. There is no GCF, so I can go straight into the solver and type all my stuff in. That's +3. And then we have a -40. So don't get it twisted. These are not what go into the parentheses. They want the parentheses. Anytime they say factor, factor is right like this with an x here and an x there. Remember that these guys that the calculator is spitting out is actually the answers. So it's x equals 5 and x equals -8. So if we were to do the math to get this next to the x, we would switch the sign. So in here, it's actually going to be a -5 because this right here is x minus 5 equals 0. Same thing with the 8. If you add 8 and add 8, this is x plus 8 equals 0. So we got plus 8 in here, and then that's your answer. So that was a long view. I think we'll be taking the test on a Wednesday, which is a short class period. So we'll probably, I don't know, take 2 days on it. We'll see how it goes. But yeah, that's the Unit 8 review, and I'm expecting the scores for this one to be much higher than the Chapter 7 scores.